Hello everyone, this is an introductory video for fluid mechanics and hydraulics, the third semester B civil engineering subject, code CET 203. At the end of studying this course, this is what you intend to achieve, listed as course outcomes. You could refer to various textbooks. Now the entire subject is divided into 5 modules, with the first one talking about fluid properties, its classification, and the fluid statistics, with the second module dealing about buoyancy and flotation, and also a little bit of hydrodynamics, taking into consideration the continuity equations in one-dimensional, two-dimensional, and 3D. Now module 3 is about fluid kinetics and introducing Bernoulli's equation and its application in venturimeter, pitot tube, orifice meter, etc. Module 4 is about distinguishing open channel flow and pipe flow and introducing a term called most economical sections and how is it varying according to various shapes of the channel, and also the flow measurement in channels. And the last module is about the specific energy, specific discharge, and categorizing the flow as critical, subcritical, and supercritical, and most importantly, hydraulic jump. Now, before you study the subject, you need to understand the applications of fluid mechanics, as the pictures say this. The pictures depicted here gives you the wide range of applications of fluid mechanics in our day-to-day life. Now, talking about the subject, the second keyword, the mechanics, the second part of a subject. Mechanics is an oldest physical science which deals with basically the moving and stationary objects provided there is a force. Those which deals with rest comes under fluid statistics, and the contrary to that is the fluid dynamics. So fluid mechanics is basically the study of fluids at rest or in motion and their interaction with the solids or liquids at the boundaries. And fluid dynamics is again further split into two, kinematics and dynamics. Kinematics is where the pressure forces are not considered, so that makes you understand what is dynamics. Now the second part of our subject, that is fluid mechanics and hydraulics. Hydraulics is a subcategory of hydrodynamics, which is the study of motion of incompressible fluids. So hydraulics is nothing but the liquid flow in pipes. Now all we hear is the term fluid continuously, and it is anything in liquid or gas phase. The first module deals about the fluid properties or characteristics, basically 4: mass density, specific weight, specific gravity, and viscosity, which is nothing but the resistance to flow, and also the fluid types as tabulated here. It also deals about the fluid pressure, that is how much force it is required per area with reference to the Pascal's law, and its application in manometer, piezometer, etc., with the impact of this pressure force on immersed planes, be it inclined or curved or vertical. The second module is about buoyancy, and when you hear the term buoyancy, all you need to hear, listen, or remember or recall is the Archimedes principle. So when a body is immersed in a fluid, an upward force is exerted by the fluid, which is the buoyancy force, and the phenomenon is hence named buoyancy. It has basically two terms, metacenter and center of buoyancy, and we do have numericals regarding flotation, and it deals with fluid kinematics, that is the fluid motion in various approaches, mainly Eulerian and Lagrangian, all taking into consideration the importance of continuity equation as equation given here. Module 3 is about the Bernoulli's equation and its application in all problems of incompressible flow where energy considerations are involved. So it's mainly through venturimeter, orifice meter, pitot tube, and also about the fluid kinematics in orifices and hydraulic gradients. The fourth module is how pipe flow is varying from open channel flow, mainly taking into account two main equations, Manning's equation and Chessy's equation. And we bring up a term called most economical, that is maximum discharge for a given cross-sectional area, and so the most economical conditions for various shapes like trapezoidal, rectangular, circular, triangular channels, etc., and also about the flow through weirs. The last module is about the surface profiles, that is when you categorize a flow as critical, subcritical, and supercritical, what are the various surface profiles obtained and what are its characteristics. And we bring up certain terms called specific energy, critical depth, conjugate depth, etc. And most important of this is the hydraulic jump, which occurs due to the abrupt transition of a flow from supercritical to subcritical flow. So this is in a nutshell the fluid mechanics and hydraulics CET 203.